Greetings everyone and welcome to the chemistry program. I am delighted to be here today to discuss this topic. Today I will be discussing the wonderful and the marvelous world of chemistry. Today I'm going to talk about how can you calculate the EMF of any galvanic cells. Calculation of the EMF of any galvanic cells. How can you calculate the EMF of any galvanic cells? The electromotive force or EMF of any galvanic cell can be calculated as follow. Number 1, E cell or EMF of any galvanic cell equals oxidation potential of anode plus reduction potential of cathode. Oxidation potential of anode plus reduction potential of cathode, or E cell or EMF equals oxidation potential of anode minus oxidation potential of cathode, or E cell equals reduction potential of cathode minus reduction potential of anode. There are three different ways to calculate the E cell or the EMF of any galvanic cells. Notes, very important notes. Number 1, oxidation potential of anode is greater than that of the cathode. Number 2, if the EMF of the cell is positive, the reaction is spontaneous and this cell generates an electrical current. For example, number 1, an electric cell made of zinc and copper where their standard oxidation potentials are 0.76 volt and negative 0.34 volt respectively. Does this cell generate electricity? Explain why. The solution: E cell equals oxidation potential of anode minus oxidation potential of cathode. This equals 0.76 minus negative 0.34. This equals 1.1 volt. What does this mean? 1.1 volt. The EMF of the cell has positive sign, so it generates an electric current because the reaction is a spontaneous reaction. This galvanic cell can be represented by a diagram as follow: Zn single bar, Zn positive 2, double bar, Cu positive 2, single bar. Another example. Number 2, a cell consists of two elements, A and B. Each of them divalent and their oxidation potentials are 0.4 and negative 0.6 volts. Oxidation potential of the two electrodes are known, 0.4 and negative 0.6 volt respectively. What is the diagram of the cell? Then calculate its EMF. Does it generate electric current or not? and why? The solution. E cell equals oxidation potential of anode minus oxidation potential of cathode equals 0.4 minus negative 0.6. This equals 1 volt. 1 volt. This means an electric current is generated because the reaction is spontaneous, and we can represent this cell by a diagram. The diagram is A single bar, A positive 2, means A it changes into A positive 2 after losing 2 electrons, and this a reducing agent. Double bar, B positive 2, single bar, B. Another example. Write the diagram for the following galvanic cell, indicating the oxidizing agent and the reducing agent. Then calculate the EMF of the cell, and he gave you the reaction that occur in this cell. H2 plus Cu positive 2 to give 2H positive plus Cu, knowing that the oxidation potential of copper equals negative 0.34 volt. How can you calculate the EMF in this cell? EMF equal oxidation potential of hydrogen, standard hydrogen electrode, and this its oxidation potential equal 0 minus oxidation potential of copper. So the EMF equals 0 minus negative 0.34 equal 0.34 volt. What does this mean? Oxidizing agent is Cu positive 2. Why? Because it gains 2 electrons during this reaction, while a reducing agent is H2 because it loses 2 electrons during this reaction. The cell diagram that represents this cell is BT dash or comma H2 1 atmosphere, single bar 2H positive 1 molar, means the concentration of hydrogen ion equals 1 molar, double bar salt bridge, Cu positive 2 single bar Cu. Very important notes. Number 1, elements or negative ion prefer oxidation by increasing the value of their oxidation potential. Again, elements or negative ion prefer oxidation by increasing the value of their oxidation potential, and vice versa. Number 2, in the galvanic cell, the electrode whose oxidation potential is higher than the other is oxidized and becomes the anode of the cell. Similarly, the higher reduction potential cathode and the lower reduction potential electrode becomes the anode. Number 3, to obtain the electricity from the cell, the redox reaction must be spontaneous, and the value of the EMF must be positive sign, has a positive sign. Number 5, if the EMF has negative sign, the cell can't get or generate electric current or electric energy because this reaction doesn't occur spontaneously, non-spontaneous reaction, EMF by a negative sign. This means the reaction is non-spontaneous. Number 4, the higher value of the oxidation potential of the element means the greater of chemical activity and vice versa. Number 6, the best oxidizing agent or the best reducing agent can be determined from their standard oxidation potential or standard reduction potential as follows. The best oxidizing agent means the smallest value of the oxidation potential. Attention please. The best oxidizing agent means the smallest value of the oxidation potential or the greatest value of the reduction potential, while the best reducing agent means the smallest reduction potential's value or the highest or the largest oxidation potential's value. A galvanic cell made up of magnesium electrode dipped in a magnesium sulfate solution with a concentration of 1 mole per liter and a lead electrode in a lead 2 nitrate solution with a concentration 1 mole per liter. This means that the two solutions are similar, 1 mole per liter, 1 mole per liter. If you know that magnesium oxidation potential is 2.363 volt and lead oxidation potential is 0.126 volt, calculate the EMF, then write the diagram or the cell expression of. In this problem, he gave you the oxidation potential of the two electrodes. How can you solve this problem? Firstly, you must compare between the two values, the higher and the lower value. The higher oxidation potential becomes the anode, and the lower oxidation potential becomes cathode. So, in this problem, magnesium has a higher oxidation potential than lead. Magnesium becomes the anode and the lead becomes cathode. Okay? The oxidation potential of magnesium is greater than that of lead. So, magnesium is anode and the lead is cathode. The EMF of this cell equals magnesium oxidation potential, which is anode, plus lead reduction potential, which is the cathode, equals 2.363 plus negative 0.126. This equals 2.237 volts. The sign of the EMF is positive. What about the cell expression of this cell? How can you write the cell expression of this cell? Mg single bar Mg positive 2 means magnesium Mg, it changes into Mg positive 2 after losing 2 electron. Magnesium is a reducing agent. Double bar Bb positive 2 single bar Pb. If you know that the standard reduction potential For both Sn positive 2 single bar Sn 0.14 volt and Ag positive single bar Ag 0.8 volt. Find the EMF, then write the cell expression. The solution. The reduction potential of silver is greater than that of tin. Silver is cathode and tin is anode. The EMF equals tin oxidation potential plus silver reduction potential equals minus 0.14 plus 0.8 equals 0.66 volt. The cell expression of this cell is Sn single bar Sn positive 2 double bar 2Ag positive single bar 2Ag. But he gave you Sn positive 2 single bar Sn and you change it. Why? Because tin is anode and the oxidation takes place at anode. Sn it changes into Sn positive 2. Another example. Write the cell expression of a galvanic cell represented by these reactions. Magnesium Mg plus CuSO4 to give MgSO4 plus Cu. Magnesium oxidizes and it changes into Mg positive 2 in magnesium sulfate, while copper positive 2 in copper sulfate it changes into copper atom. So you can write the cell expression Mg single bar Mg positive 2 double bar Cu positive 2 single bar Cu. Firstly, you must identify the anode and the cathode, the oxidation and the reduction to write the cell expression. You can't write the cell expression if you don't identify the oxidation and the reduction process. Another example, number 2. Zn plus 2H positive to give Zn positive 2 plus H2. Zn single bar Zn positive 2 double bar 2H positive molar single bar H2 1 atmospheric pressure dash or comma Bt. Bt must be written at standard hydrogen electrode. You can't make hydrogen electrode without platinum, so you must write platinum. Another example, calculate the EMF in volts produced from each of the following reaction. This type of problem very important. He will give you the reaction and you must identify the oxidation and the reduction, the anode and the cathode by another way. Calculate the EMF in volts produced from each of the following reactions. Number 1, Mg plus Cl2 2 gives Mg positive 2 plus 2Cl negative. Number 2, Cl2 plus 2Br negative to give Br2 plus 2Cl negative. There are two different reactions and you must calculate the EMF. You can calculate the EMF by knowing that the reduction potential of magnesium Mg negative 2.363 volt and bromine, the oxidation potential or the reduction potential of bromine 1.065 volt, and the oxidation potential of chlorine equals minus 1.36 volt. Number one, the EMF of the cell, of the first cell, the first reaction equals oxidation potential of magnesium, which represents anode, plus reduction potential of chlorine, which represents cathode, equals 2.363 plus 1.36 equals 3.723 volt. In the second reaction, the EMF of the cell equals oxidation potential of bromine, which represents anode, plus the reduction potential of chlorine, which represents cathode in this reaction, equals minus 1.065 plus 1.36 equals 0.295 volt. Questions. Give reason. Electric energy is considered as the most important and the safe form of energy for environment. Again, electric energy is considered as the most important and the safe form of energy for environment because it is from the cleanest forms of energy. It is from the cleanest forms of energy that doesn't cause pollution. Again, because it is from the cleanest form of energy that doesn't cause pollution. Number two, second question. The anode in the galvanic cells is the negative electrode. The anode in the galvanic cells is the negative electrode. Why? Because, or as, the oxidation process occurs on it. Oxidation process occurs on it, takes place on it, which leads to the accumulation of electrons and becomes the source of electrons. Again, why anode negative charge in the galvanic cells? Because the oxidation process takes place on it, leads to accumulation of the electrons and becomes the source of electrons. Number three, the cathode is the positive electrode in a galvanic cell. The cathode is a positive electrode in the galvanic cell. Why? Because the reduction of the cations occurs on it. Copper 2, copper positive 2, accept 2 electron and it changes into copper. The cathode in a galvanic cell is negative sign or has negative sign. Why? Because it is acceptor of electron. Acceptor of electron means the electron moves from the other electrode to this electrode, from the anode to cathode. The electron has negative charge, and the negative charge moves towards negative or toward positive. Okay? Toward positive charge, opposite to its charge. Opposite to its charge. Number four, the importance of salt bridge in a galvanic cell. Number 1, it connects between the solution of two half cells indirectly. Number 2, it neutralizes the excess of both the positive and the negative ions which forms in the solution of the two half cells as a result of the oxidation and the reduction reactions in zinc and the copper half cells respectively. Number 3, the absence of the salt bridge, what will happen in the galvanic cell, lead to stopping the oxidation and the reduction reaction and consequently stopping the flow of electric current in the external wire connecting between the two half cells. As we came to the end of our program, I hope everyone found it interesting and had a good time watching us. Thank you, and till we meet again, it's a goodbye. I wish you the best of luck.